Good morning to everyone and welcome to the MMID Coding Workshop Series. So today we have another fantastic workshop instructed by Grace Supp. She is a master's student in the Department of Medical Microbiology and Infectious Diseases, and she's supervised by Drs. Tim Booth and Natalie Knox, and she is also the coordinator of the workshop series. So without further ado, Grace, the floor is yours.
Thank you, Jill, for the introduction. And hello, everyone. Today, I'm going to introduce you to R programming language and its companion RStudio interactive development environment. I will also refer to our previous Bash workshops as it pertains to coding syntax and when you would use Bash or R for bioinformatics analysis. Just a reminder that our workshop is being recorded and will be available on YouTube channel so you can use it as a reference. We kindly ask you to please hold your questions until the Q&A session at the end of the workshop. Also this week, we will hold an extra 1.5-hour Q&A session on Thursday, so that's tomorrow from 9 to 10:30 a.m. If you have any questions regarding the materials related to previous workshops, feel free to drop in and ask questions. Once again, like the intro to Bash workshop, today's workshop is intended to provide introduction to R and RStudio, which will serve as a foundation and prepare participants for next upcoming R workshops. By the end of this lecture, participants should be able to do everything outlined in these learning objectives. So what is R and how is it different than Bash? R is a programming language developed by statisticians to be used for statistical computing and data visualization. Just like Bash, R is also part of the GNU project, meaning that it's an open source and free, and have a wide community involvement for package development. Once you have base R installed in your computer, you can access R console from your Bash terminal, command prompt, or simply open the R program. If you open the R program with the base R interface, this is what it looks like. RStudio is an integrated development environment for R language. In short, RStudio is used to build applications for R by combining multiple developer tools into a single graphical user interface. So what you saw previous slide, everything is here, but it has more panels. So RStudio is dependent on R language, and that's why you need to have R installed first, and then install RStudio in order to use it. In case you're curious, integrated development environment is what programmers use to build computer programs, mobile applications, or web pages, and so on. For example, you've probably used many different applications on your phone or have experience playing games. Most of these programs are developed in programming languages such as C or Java or Python using Visual Studio. And just like that, RStudio is the same developer tool, but solely used for our programming language. So by using RStudio, you are already set to become next generation programmers. Now, based on the feedbacks I received from my introduction to Bash workshop, participants wanted to know when you would use Bash or R, what kind of analysis are suitable for different programming language. First and foremost, R is very good at handling large data points. But when I was a co-op student, I had to deal with large data, like file size, with over 100,000 data points using Excel. So Excel is very great at handling smaller data sets and offer awesome functions such as pivot tables, macro, and easy table visualization. But unfortunately, Excel crashed on me a lot when I tried to analyze large data. So if I tried to save the file, it would take more than 2 minutes, sometimes doesn't end up saving, and it would, for a very simple task, it just crashed on me quite often, which gave me quite some headache at the time. But there are definitely other programs that can handle large data and cool visualizations such as Power BI, Tableau, or Prism, but these are paid platforms. For labs with limited fundings, these options could be costly, but R is free, powerful, and you can make cool plots just like those paid platforms. And you can also make scripts to automate analysis so that results are reproducible and easily repeated across different labs. If I had known about R when I was doing my co-op, I would have definitely used it. Now, I definitely recommend it to anyone who is interested in doing analysis and visualization. Most importantly, just like any language, if you know one programming language, you can easily learn another one much faster. So here is an example of workflow of some analysis that you can do in Bash and R. Bash is more suited for data processing and analysis, whereas R is more suited for data transformation, statistical analysis to create beautiful plots. For example, let's say you work in the SARS-CoV-2 or RNA sequencing lab, where you obtain genome or RNA sequencing data from nanopore or Illumina sequencer. You get your sequencing results in FASTQ format, and within the reads, it will probably have primers, adapters, and barcodes, depending on what you use, attached, which you don't want to have it in your final output. So you can remove these sequences by using Bash programs like cutadapt, for example. Now, we only want to keep the reads that maps to our reference sequence. Again, in Bash, you can use a program called minimap2, for example, to align reads to a reference. And just a note, if you want a refresher on Conda environments and genome assembly, here are the links to watch our previous workshops again. So now you have your results generated as a table. And imagine you have to give a presentation at a conference. It's probably better to show summary graph than the table, if possible. So this is where R comes into play. Sometimes table results from Bash programs can't be used right away to plot the results. You may also have lots of data files that you want to combine into one file. So in R, you can combine and transform data very quickly from multiple files into one, and probably generate a simple table of summary. And also, if you have codes written in a script, assuming that your input files will always have the same format, anyone in your lab will be able to run the script and produce the same type of output in R. And this part will be covered in more detail by Molly next week. Next, once data are nicely transformed, we can use it to make awesome graphs. And this is one of the main strengths of R. So this part will be covered by Sam and Mackenzie, where they will teach us on how to visualize different types of data. These are just an example. And if you do a research involving phylogenetic tree, R offers a package that allows you to generate a nice tree. And for example, if you have a SARS-CoV-2 data, which I work with, you can use ggtree to visualize phylogenetic relationship between alpha, beta, delta, and Omicron variants. So this part will be covered by Taylor, where she will teach us on data visualization using ggtree. And although not part of our workshop series, there are also lots of other packages available for different types of visualization. I provided a short list of packages here so that if you ever wanted to try something new, you know which packages to look up for on Google. Now, there are also several packages in R that offers very in-depth analysis on specific data type. For example, you can do RNA-seq analysis and visualization all in one package called DSeq2 or EDGE-R for differential gene expression analysis. These packages offer statistical analysis specific for RNA-seq data and generate something like PCA, heat map, or volcano plots for visualization. And this part will be covered by Jesse, and he will teach us all the basics of RNA sequencing, data analysis, and visualization. Lastly, R offers numerous machine learning packages to develop and test your models. Machine learning has many applications, such as predicting antimicrobial resistance or predicting correct variants of concern for SARS-CoV-2. So machine learning will be our last workshop of the series and will be covered by Vazena, where she will introduce us the basics on how to perform machine learning in R, because you can also perform machine learning in Python or different programming language. So stay tuned for these upcoming workshops as you'll benefit a lot from these. I also wanted to mention that in the field of data science, Python and R are two commonly used programming languages. Just a note, Python is a programming language for software, web, or app developments and machine learning, whereas R is designed specifically for statistical computing and data visualization. But Python is also an open source and free language and easy to learn as well. And you can use both Python or and R in your research or just R. It's totally up to your preference and your needs. With that, let's begin by installing R and RStudio on our computers if you don't have it already. On your left is base R interface, and on your right is RStudio interface. As you can see, base R has separate tabs for script, console, and plot, whereas RStudio have everything nicely organized into different panels in a single interface. So it's totally up to you whether you choose to use Bash, R, or RStudio. So here are the links to base R and RStudio webpage if you want to learn more about these programs. And here are the resources that I really like and thought would be useful for beginners. There are also so many more free books and blogs available on R. I recommend you to browse through these books and see what you like the best and start from there. So now if you have Windows or Mac, installation method is very simple and very similar between two operating systems. Just in case if you run into trouble, I also included some YouTube videos that will help you to follow along in different platforms, and they explain it really nicely how to install in detail. So the first thing you need to do is select the CRAN network that's close to your location. You can scroll down this website and you'll be able to find CRAN mirrors for different countries. CRAN is a web server that stores up-to-date versions of code and documentations for R. So since I am in Manitoba, Canada, I'm going to select this Manitoba Unix user group. Once you've selected your mirror, it will automatically take you to this page with download links for different operating systems. Here, if you are a Windows user, click the version for Windows. If you're a Mac user, click the version for Mac. And once you download an executable file, double-click the application and install using default options. After base R is installed, open this website and scroll down to the bottom. This page will automatically recognize your operating system and offer to download RStudio for Windows or Mac. So click the blue button and download. And if it doesn't appear there, if you scroll down a little bit further down, you'll see this list of all installers where you can choose the program from. So again, install using the downloaded file with default options. If you've installed RStudio, you should now be able to find the application and open it. And this is how RStudio looks like without any customization. Whenever there is a new update, RStudio will automatically prompt it for you, so you don't have to worry about it. But for base R, occasionally check if new version is available on CRAN website to keep it up to date if you don't open that program regularly. Now, if you're on Linux machine, we will use terminal to install the program. So here is also a guide video available on YouTube in case you run into a problem. So this is the approach I take to install on Linux. So open your Bash terminal, type the following sudo commands to update and install RBase. And remember from Jill's workshop that -y indicates that do not ask for confirmation. So this is a very quick installation. Once finished, you can simply type R in your terminal or sudo -i, meaning interactive, and type R to open our console. So you can use any of two methods here to open our console. If you do, then you will now have R prompt where it's now arrow, and you can do your R coding there. If you want to quit, then you can use Q with brackets, and it will also ask you to save workspace image where you can type one of the letters here, yes, no, or cancel. So just a note that function name followed by brackets in this is the syntax for our language. And now unlike Windows or Mac, Linux version doesn't pop up automatically with that blue button. You need to scroll down and find Ubuntu RStudio version. So we're going to download from the terminal. So right click on this file and then copy the link address. In your terminal, type wget, then copy the link. and it will download the file in your current directory using the terminal. And next, you can install RStudio using sudo command and with a downloaded file. And you should now be able to find RStudio in your programs list and open it. To make your coding experience fancier, I will briefly show you how you can customize your RStudio. If you have your RStudio open right now, you should see 4 panes in your interface. Actually, this will not be present if you didn't open any script or file. And this is where you can edit your script or R markdown and view data as well. Environment and history pane is where objects or plots you create are listed here. And if it's empty, then there is no objects created. Console pane is where R codes are submitted and results are returned. Lastly, this navigation pane can be used to switch between folders, show plots that you create, or display help page. If you're not a big fan of the current theme, font, or size, you can change it by clicking Tools here and go to Global Options. A customization prompt will pop, and you can go through these slowly and modify the settings to your preference. In Appearance tab, so one thing I do is changing the appearance. You can change your theme to dark as well as change the panels. So if you want to put your environment history here, you can change it and put your console here. You can do that as well. So here is an example of how I customize my RStudio. I prefer dark theme better. You can do so by changing the appearance. So my RStudio theme is modern. Editor theme is idle fingers. And I like my navigation and environment panes being on the left. So this is how I did it. So it's really up to you. Set up the way you like. Now that we have RStudio fully functioning, let's go over basic commands in R. R commands are similar to the bash commands. For easier reference, I included bash commands side by side. And also keep in mind that just like any programming language, R is also case and space sensitive. So when you run a program, something doesn't work, always make sure to check, did you put in the right function name? Like, did it become like a capital G instead of a lowercase g or something like that? Because those are the ones that are really hard to find, but will solve most of your problems. So next several slide explains in detail on how to navigate, create, rename, move, and copy a directory in a file. You can always refer back to these slides, but for today's workshop, I will go over the steps in RStudio. And so just before I move on, this is a slide from Intro to Bash explaining the folder structure. R is also the same. It follows the same convention as Bash. So if you want to change your working directory, this is how you would type in your console, but you have to use the quotation mark. Okay, so I'll open my RStudio now. Okay, so I have my script open, but all right, so this is my console. So in RStudio, you can change your directory by clicking or in console. So I just changed the theme to light again. This is my environment. My environment is here and my navigation pane is on my left. So here, let's try to change manually like your folder structure. So you can actually click this and go into the folders to change directory, but this won't set your working directory. What you can do is in this navigation pane, you can select, so there's multiple tabs here, but we're gonna go to File and click ... So it will pop up the folder structure so you can click wherever you want to go for your choice. I already have my working directory set as this folder. And one thing, if you change it manually using this, you have to set your working directory by clicking More and set as working directory. If you do that, then the code will automatically pop up in your console. So the second way I wanted to show you is exactly this. You can use set working directory function. So this is the function, and you just wanted to put your folder path inside the code here, and it will automatically set it for you. And you can also use relative path, just like in Bash. So remember, if you type double period, then it will move up a directory. So now you can see that my directory has changed to desktop. So if I want to go back, I can, if you press tab, it will also show the list for auto completion. And I can just go back into my intro to R. So this is very simple, easy to change your directory. If you're more of a person who likes clicking things, this is another option you can do. So now if you want to know where your working directory is, now let's say you forgot, this command is going to tell you where you are at. So if you don't put in anything, it will automatically just like pop up your current working directory. And next, you can create a file. So to create a file, you can go to the top menu and click new file. Choose the file type you want. So R markdown, then you can click and it will pop up new one for you. So just to remember that if you do this, it's actually not saved. So before you work on this script, I would recommend you to save this file so that you don't lose anything. Another way to create your file is by using file.create. So this is a way to create a file. Let's see if it's going to pop up in our working directory. Yes, it worked. Then we got our script. So it's empty right now because there's nothing in it. So this is another way you can create your file. You can change the extension to whichever file you'd like, or you don't include it, but it will still be there. Now, in order to create a folder, you can click this new folder and add the name, and it will pop up new folder for you, or in console, you can directory create function. And again, in the double quote, add the name, it will create a new folder for you. If you want to change a file name, you can rename it. You can go to Windows Explorer and like just manually change it, or you can use file.rename script. I want that to be changed to new name.r. Now take a look at here. If you tap, so now it's renamed to this. If you want to move a file, it's a bit complicated in console without any package. So for beginners, I'd recommend you to use the navigation pane. So in navigation pane files, you can go here, select a file, create more, go to more, and click move. So there's copy, copy to, or move. So you can select whichever location you wanted to put it in. Okay, so I'm going to put in hello2. Then it will now be in hello2. Okay, so now to copy a folder, so now hello2 has a file inside. You can do it manually by clicking this and also doing copy to or copy and enter a name. You can also copy a file. So copying a file is much more simple. So we're gonna, let's create the file again. Let's see. So if we want to copy a file, new file, you can do it by simply typing your file name into the new file copy. And now you have a new file copied over. So now you know the basics on how to navigate or create stuff in R. This is really all there is to it. So let's get a little more advanced with R scripting. Okay. Okay, so I'm going to jump to slide 59. So, and at this time, we will actually install a package, load library, and write a simple R script. So due to limited time, I already provided a script so you can follow along. So before I go into scripting, in R, I just want to explain some things for you. So we work with packages. So package is a bundle of code, data documentation, and tests that is easily shared with others. So package is similar to a program or conda environments that you can download for bioinformatics analysis in Bash. So here are some of the popular packages for each analysis type. You'll probably get to use some of these packages in upcoming R workshops. If you want to get fancy with data visualization, you can also create an interactive plot using Plotly. And to get even more fancier, you can also create a dashboard using Shiny. So for some COVID-19 results, this is how dashboards are created. So just to show you, so this is Plotly. You can actually generate an interactive plot. If you hover over, you'll see some cool things here, like values. And here are simple codes on how to get started. Also Shiny. So this is a dashboard from RStudio. So there are multiple examples you can try. So if you wanted to create something fancy, you can definitely do this. Here, this is just an example from someone else's. Create a plot and it will pop up, create a plot for you. So there are so many different packages that's available for you to explore for different types of analysis and visualization. And there are, so now another basic thing is that there are different types of R vectors that R can store information in an object. But since the list is too vast to explain everything in 1 hour session, I included an online book here and that explains what each R vectors mean and how you can create them. So today I just selected a few vectors that are commonly used in R. Atomic vectors are simple vectors of data. So it's if you assign some values into an object, it will store these values here. And if you print, it will print out these values stored for you. And if you store any numbers into an object without any quotation mark, so 1, 2, 3, 4, 5, this is automatically recognized and R will store it as doubles. Now, if you don't want to keep numbers as doubles, but instead an integer, you can tell R to store these values as an integer using L after your number. And here, if you store text instead of numbers, you need to use quotation mark. You can also store numbers as a character if you put a quotation mark around here. And R can also store logicals, which are true or false values. So here is 3 greater or equal than 4, false. Yes, and also logic, if you store a logic object, it will print out these values for you. And lastly, factors are categorical information. So if you specify your values as a factor, you can create an object. R will be able to create levels of attributes for you, just like here. So I have male, female, female. And if I wanted to check how many levels are there, female and male, there's only 2. So that's what factors are. And let's try to apply some concepts into practice. So now imagine if you're a teaching assistant for a Pokemon bioinformatics course, and your supervisor provided you with a class metadata and would like you to perform simple analysis as listed in our script that I provided to you. So you can download our script and our markdown from the GitHub page as well. So I made a fake class metadata, which can be downloaded from this link. And details are available in the following slides, but I will go over these concepts in RStudio. So let's open up. So here is my R script. You'll be able to, you also have the exact same thing. So here, so first thing, if you want to start from scratch, you can create your R script file. Just remember to save the file before. And then, but I made a script here and it's already open, so I'm not going to do that. So I'm just going to go over what each things mean. So first thing, you need to, in order to work with anything, you need to load the data. And so this is just an object that's being loaded here. And I'm skipping the download part. I'm just loading it directly from the GitHub link into my environment. If you downloaded the file and put it in your folder, like somewhere here, you just have to specify this folder and then the file name. So this is a way to do it. And remember, if you put a # in front, it will be commented out. So if I don't want to use this option, but I want to use this instead, you can unpound it and so on. Okay, and to run the command in R Markdown, you can put your cursor on any of these and press Control Enter. So it will run the code for you, or you can highlight the section that you want to run all at once and press Control Enter. The same thing. Now we want to view the data. So I'm going to see if it's actually the one I wanted. So I can see all the file contents here. So this is a table version of the data visual or table visualization for the loaded data set. Or you can also print out the metadata into a console. You can see this exactly instead of opening a new tab. So I just closed it, but you can also see the file content here. If it's large file size with multiple columns, I definitely recommend you to use view function. So this, if it's small file, then you can just print it out in console just for checking purposes. So next, once we have data loaded, you need to install some packages. So for today's, I'm just showing a simple method on how to do stuff. So I'm not going in details on how to work with different package, but useful package that will probably be used quite often in our data analysis is tidyverse. This also includes dplyr, ggplot2, and tidyr, and different packages in one. So if you install this, you'll already have some of these packages installed for you. I already have the package installed, so this will not work if I do this. So if it's your first time, you've downloaded R just now, then you definitely have to run this. But if not, then you don't have to. And you can go straight into loading your library. So if you load your library, it's going to tell you which packages are attached and are ready for you. Okay. And so the convention always follows the same. Unless you're using some packages from Bioconductor, there is a different way to install it. So that's just, that's more advanced for different types of packages like dseek2. And I'm sure Jesse will cover it in more detail. Okay, so now we get to the fun part. So here is a task that's assigned for you. Your supervisor wants you to determine how many students are in your class. So now what you can do is for this one, I made it purposely so that row number matches the total number of students. So in base R, the function nRow is already available. So you can just use nRow and you put your object. So our data is metadata, so like our object. So if you put your object into this bracket, then it will recognize how many rows are there. There are 20 rows. Let's check if this is true. Again, you can actually use view function, or you can click on this and it will pop up table for you. So we have total of 20 students. So that is correct. And now, if we want to determine how many columns are in your metadata, same type, but instead we switch the word to column and metadata. So if you run this and console, it's going to tell me 9 columns. So that's really not that helpful. I want to know what actual metadata are collected. So we can check which metadata were collected using call names function. Okay, so now it's going to pop up the list for me here, and you'll see exactly the same thing. Okay, so that's pretty cool. So I got student name, student number, age, and there's addresses. Okay, so now the next step is to print out the row contents. So I want student names, like all of the students' name that's they're enrolled in this class. In order to do that, you can actually use the dollar or money sign. So money sign is a way to specifically get the column value, column information from a data frame. So here, yeah, so if you have a file name or your object name and a dollar or money sign, then you wanted the stuff from your student name. So you actually do this. If data frame is available, it will actually pop up different column information for you. So you can do student name. And if you do this, it will also show you all the list of students here. Literally just printing out these values from the data, from the object. Okay, so now for simple statistics, if you want to, so this is just to show. So for today, I'm just gonna use mean function. So now my supervisor want me to calculate the average age of all students in this class. So average age, I just want these values to be used for my mean calculation. So again, we just learned that money operator. So within the mean function, include metadata. And from metadata, I want to use age. And you can tab complete and it will also show you this as well. Now it's going to calculate the value and says that 24 is the age group. And now to get a little bit more challenging, just for fun. Now she wants, my supervisor wants specifically Pikachu's student number. So let's see where it looks like. So Pikachu is row 20 and the student number is right here. I mean, this is a way you can do it, but if you have metadata that's over 100,000 data points, it's kind of hard to scroll down. It's also going to be a bit slower. And so if you're assigned such task, first thing you want to do is you want to find out a row that has Pikachu's name on it. So this function will find out, like double equal sign means find a row value that is equal to Pikachu. And then from there, obtain the student number of this row. So if you do this, you're going to get same number. Now you can also do this for other, let's see, other student. And you get different number. See if that's true. Yes, it is. So this is one way to extract specific value from a metadata that's very large. Okay. So now next, using a ggplot. So to summarize this, our findings, we're gonna create a simple graph. So I'm going to store my ggplot into the plot object. So if I do this, and my x's will be year of study, age, and I'm gonna change it. I'm gonna group it by major of study. So if you do this, it's actually, if you click on it, it's not gonna show you anything because it's a graph. So instead, if you print it out in console, it's going to show the plots here. You can zoom in to see. You can take a screenshot if you like, or you can right click and save image as well. This is just one way to do it. Now that it's a bit too difficult to see because it's too small, I don't really like this gray background. So you can add a little bit more stuff to it, change X label. So here, I don't want this underscore. but it's automatic. This is automatic because that's my column name. So instead, we're going to rename it using X label and just remove the underscore. If you run this code and do this, now you have much more sophisticated graph. Again, you can save it and you can change the size as well. Okay, so really this is it to the R scripting. So just for me to show you guys how to do it simply. So now going back to our slide. So I skipped through to slide 83 because all the information there are exactly the same as what I showed. Okay, so now to apply all this and put it into our R markdown. Because you have generated these results, but you can just give the script to your supervisor and say, hey, run it in your program and you get your what you want. So instead, to provide a report, you probably want to create some kind of PDF output or HTML, whichever that has everything nicely organized. So for today's practice, you can just copy and paste your codes from scenario 1 and to create a beautiful PDF output using R Markdown, or just refer to my R Markdown that I created for you. So it's really simple. R Markdown, in order to create one, you can just go here and it will pop up a new prompt and you can rename your file. So new Markdown. Then this becomes your title that's written on your Markdown, and you can put your name for authorship and date will automatically pop it for you. Or there's a different options you can use. So this is totally up to you. So you can use HTML as an output or PDF output and just click OK, then it will create a Markdown for you. So this is default code chunk. So anything that's embedded in this bracket. So here, I'm going to show you 3 of this are to indicate that this is our code chunk, and the chunk with another 3 single quote. And you can put your code here. So if you don't put your code in here, then everything you've done, like type here, will become a text. I wanted to just show you. So go back to the Files tab. So I'm gonna show you the PDF file. So this is what it looks like. If you don't put it in a code chunk, it will be recognized as a text, and everything here is written here. And for headers, if you want to have like a tables of contents, then you can. So here, headers. Anything that's after the pound sign will recognize as a content, and it will like have a tables of contents generated for you automatically. You can also change the size of the header by number of pound sign you have. Okay, and so these are just explanations on how you can create stuff. So if you don't have a space after a bullet point or after this pound sign, it won't create a it won't be recognized as an option, and it will just be recognized as a text, and you won't get that nice bullet point or header. So these are just things that I wrote for you, so you can reference it and create your own report. And one thing I find it really important is to always include a date when this file was created, or it's sort of like a version control. If you refer back to like a previous document but realize something is omitted, but if you don't have the date written, it's really hard to find out what's lost, and hard to kind of like go back to where you can edit it. So that's just one thing to do. And in R, if you want to embed a function, you can include this single, I don't really know what this is called. It's not really code, but it's the one that's under your tilde sign. So anything wrapped in this little thing will be recognized as a function within the text. So you'll be able to see this automatic. It will automatically generate the date and time for you. Okay, so I just copied everything from script 1 and put it into a code chunks for each. So, and if you want a new page break, so you don't want everything to be like following line by line, you can add /new page and it will skip some parts and go into the next page. So you have nice, much more easier to see visualized PDF report. Okay, so the first thing really, you can type your, let's say this is like loading a data. You can include the code chunk's name by typing here, or you don't have to. I often don't because I like to do everything, more than one thing in a chunk. So yeah, so exactly the same. If you want to run the code chunk, you can do the same, just control enter and it will run it for you. Sometimes you can change option where here. So here is a version. You can preview in window or preview in viewer pane, show, so chunk output in console or inline. So this is what it means. You can put an output here or put an output here. So right now it's an inline. So if I do this, now it's going to show chunk output here. So this is really all to there is for our markdown. Obviously, there are more great resources available that you can refer to because I only have limited time and I'm not really an expert in R markdown. So always try looking into different resources. There are so many great things you can do with markdown. So exactly the same thing. You just could put the code here and you'll get your results. And yeah, so at the end, so here, let's say if you do this, now it will plot an output here. If you don't like this, you want to use zoom function here. What you can do is you can change chunk output inline to chunk output in console. Now it's going to say, do you want to delete everything? You can keep it or delete it. Oh, I'm just going to keep it, but let's also run this. Now it will output all the stuff outside of this markdown. Yeah, so this is exactly the same. I included resources that's directly related to our markdown here. So that's for your reference. Okay, so now, so everything I talked about is all mentioned in the slides here. You have it on like with your, yeah, you have it with your materials. And at the end, if you run the neat, it's going to generate a PDF output and you'll see this PDF file and this report. So that's really it for today's workshop. I actually expanded my time of session because I got feedback it's better to go slower than rushing through everything. So I hope this was better today. And by the end of this workshop, you should be able to do all of the things outlined in this learning objectives. And so if you're a complete beginner, there's a great resource I wanted to introduce you. It's a Swirl. So Swirl is a programming language. It teaches you R and data science interactively in console. So it's like you're getting one-on-one tutor. So how to do that? If you don't have it, remember to install Swirl. I already have it. I think I already have it. Oh, so okay, it was on different computer. So then if you have it, now we're gonna load Swirl. So if you ever open your R, then you can load Swirl using library Swirl. And then now it's gonna tell me, okay, so Swirl is ready. So to start the Swirl, you're going to use Swirl and brackets. Now it's going to ask me, what should I call you? Okay, you can call me Grace. And then it's going to tell you how to do stuff. So like, let's say 1, and it's very interactive. So if you're a complete beginner, this is one way you can learn R much faster. And then go into different resources like the books, then it will make sense much better. Okay, so at the end of your session, I really don't save it because if I always generate a script and it just adds extra to our memory. But if you want to keep everything exactly the same as the way it was, then you can save on your way out. Just go to the session and save your workspace. And another thing is that our documents have lots of cheat sheets available. So you can find the resources in RStudio. So there is RStudio docs. You can go to it's already here. So help, there is docs, cheat sheets. If you want to go more browse, then you can browse different stuff. It will be downloaded. So you can do that. And it's already like a beautiful cheat sheets are available. So that's why I didn't really needed to make one for you guys today because RAs already have great resources. Okay. So the next, if you wanted more practice, here are some free healthcare data sets that you can use for practice. So again, COVID-19 cases, this is one I use quite often. In health info base, if you go to CSV file, click, you can actually get the metadata or case numbers based on provinces, date of sample collection, and so on. So if you want to make graphs using that for practice, definitely go ahead. And also we have our own VirusSeq portal for Canada. So if you wanted to get some metadata on Canada's SARS-CoV-2 sequences, you can do so as well. And BC offers data catalog, so it's free. You can download many types of data and combine. So it's good for combining data, tidy. So that's where you can get your resource from. And there are many other websites available for downloading such practice data set. And so here are helpful resources to get you started on R. So if you're in computational genomics, this book is greatly recommended. And if you're wanting to learn more about R Markdown, here are some resources that are available. There are also more than these ones out there. And lastly, I wanted to say that we have upcoming R workshops. So it will be great. All of these stuff I talked about briefly will be covered in greater depth by our instructors in following workshops. So I highly recommend you to register and attend these workshops because they are an expert in these fields. They've done it more, they've done it very long time or use it every day. So they'll be able to answer some of the questions that you might have even better. Okay, so with that, I'd like to thank you all for attending today's session. And great good luck with coding. And if you have more questions, you can also come to our Q&A session tomorrow. Thank you so much.